Okay, a quick video on the informal test for 17 Feb. If I have something like this, an equation to solve for x, okay, the first thing I would want to do is get this in standard form. After I've moved everything over, got it in standard form, I can use my quadratic formula, okay? So I'd use my quadratic formula. Over there, you can see I divided by the coefficient in front of x squared. This is allowed if it's an equation you're solving, okay? Not if it's an expression, then you have to factorize out. But for an equation, if it's equals to 0 like this, I am allowed to divide away with that 2. Okay, I would get the same answer regardless, but then I can substitute it into my quadratic formula. I'd then simplify. I didn't have a calculator, so just confirm that this is correct. If it's simplest surd form, okay, if the surd is like a perfect square, like this one is 15 squared, right? You need to simplify it to a number, and this I can still simplify further. Always simplify as far as you can, okay? These two different numbers by plugging either the plus or the minus from there, okay? Always go to your simplest surd form, use your calculator, and if it's possible to get to a number, go to that number, okay? So, for instance, 3 or negative 12, okay? Simplest surd form just means you'll leave roots and you won't go to decimals. Okay, now, the second question I've already written in standard form here, so I also took everything over to one side. Since it's an equation, I can divide by the negative in front. It's negative 1 in front. Why did I have minus 6? Let me quickly fix that. Okay, so I'll fix that quickly. Becomes plus 12 there. Okay, then I can put this into my quadratic formula once again. Okay, when simplifying this, again, I didn't have a calculator, so just compare. Simplest surd form, so I go and check. It was 121 in there, which is just 11 squared, so it was plus or minus 11. If you put that in, you should get negative 1 and negative 12 as answers. Okay, so it's the same type of process as the first question. Okay, so I'm just going to move this down. Okay, so let's see. This question then. Question 3. Okay, so this one is also not in standard form. To get something like this into standard form, since it's an equation, I can just multiply with the LCD. So multiply with the LCD both sides, or every single term, right? I'm going to multiply with the LCD and I'll get this. Okay, after distributing in and simplifying a bit, I get an equation like this. Now I can immediately use the quadratic formula with this, or I can see that I can divide by 4, which again is allowed since this is an equation, okay? And it's also allowed only to multiply with the LCD because this was an equation, not with expressions. You have to keep your LCD with expressions. Okay, so then on this I can factorize and I can get my answers. X is 5 or X is 1. Okay, if I move quickly with this, just pause the video. Luckily you can do that. Okay, so the next one, nature of roots. Okay, on questions involving nature of roots, okay, what you're going to have to do is calculate the delta. Okay, so delta is equal to that b squared minus 4ac. Also, if they ask you to state something about the roots or to prove something about the roots without solving, it means you are going to use this delta. Okay, so then if this is my equation, okay, it's already in standard form, I can just calculate my delta, which is that, substitute in my values, and if I get something like negative 7, remember, we have to state something about the nature of the roots. So I'm going to have to say no real roots or non-real roots for this specific function. Okay, that's what a negative means as my delta. Next thing, if I have something like this, first I'd go and write it in standard form. Again, I can, since this is an equation, I'm worried about roots, divide by the number in front, but I don't have to. I can do my delta without using that because, right, my A value will just change, my C value and my B value, it will be in proportion. It'll still work out. So I just use those values directly and got a number like 9 plus 56. Again, confirm with the calculator, okay, since I don't have mine. This is then 65. It's larger than 0, so it must be a real root. We have to state that. Since it's not equal to 0, we know there are 2 unequal roots. Don't just write unequal roots, write how many? 2, okay? The next thing is this is not a perfect square, which means that it is irrational, Okay, delta is not a perfect square. Okay, these are the types of things you should state with nature of root questions. Okay, there was a 2b where they asked you to solve something regarding this equation with 4m in there. Okay, now I went and wrote this in standard form. Okay, I could potentially actually divide by the m both sides. Okay, as long as m is not 0, that's allowed with an equation. If m was 0, then this thing would just be 0 is equal to 0. There wouldn't be an x to solve for. It would be true for all real values of x. Okay, so I'm not too stressed about that. Okay, so I can just do the delta even without dividing by b again. So if I'm unsure, I can just calculate my delta. My delta would tell me that this is then this, which simplifies to 0, which tells me if m is a real value other than 0, if it's 0, it's just a 0 function. If m is a real value other than 0, it would have one real root whenever delta is equal to 0. Okay, so the next question becomes complete the square for an expression. Okay, now I got a question about this as well. For an expression, how does that differ from completing the square for an equation? Okay, the difference is I'm not allowed to divide away with anything, right? If I want to get rid of that 2, I'm going to have to factorize it out, okay? And I'll leave the inside. Now I'm going to go and use the inside in order to complete the square. So I'm going to use the inside b value over there. Do my normal routine to find which value I must add and subtract from this in order to make it a perfect square. I go and I add the 9 over 16 and I minus the 9 over 16 from this expression. I just leave the 2 outside there. It's chilling out there, right? It's been factorized out. I don't care about it. I'm factorizing the inside now. Okay, then I use completing the square. It would be the bracket now becomes the square root of that thing, the sine of that thing, the square root of that thing inside there, plus then the terms that are remaining. This is my perfect square, the first 3 terms. The 2 terms that are remaining is going to be my new constant. Again, confirm just with the calculator if I'm correct. I didn't have mine on me. Okay, so now the last thing that's left is I can distribute back this 2. And there we go. There is this expression completely completed using completing the square. It's been factorized like this for an expression. Okay, good. So I'm not solving for x. I'm just doing this. Okay. The next one, they asked us to solve by completing the square. Now the difference is I can divide away that 2. Okay. Now, after dividing away that 2, I'm just going to take the constant over to one side. That's what I do in solving it. Then I can add to both sides that number that we determined, b over 2 squared. So there we go. I added to both sides. This side is now a perfect square. And I can calculate the other side, and this side I put the perfect square, the square root of this thing, the sine of that thing, the square root of that thing. There we go. Is equal to 53. Now, when taking the square roots in order to solve this, remember your plus or minus. Remember the plus or minus when taking the square root, so that 2 goes and vanishes because I took the square root over, and plus or minus. Okay, then I take the 5 over 2 over to the other side. Okay, and there I get my answer in simplest third form. I could have written it as one single fraction, and I could spread it out and say x is equal to negative 5 plus root 53 over 2, or x is equal to negative 5 minus root 53 over 2. Sorry, not over 4. Okay, so there we go. That would be the solution. Okay, the next one then. Okay, so this one, question 3. Okay. Over here, they have given us an equation, or an equation here with an m value. We have to show it has non-real roots, which means whenever they ask us to show something about the roots, especially if it's non-real, if there's 1, if they're equal, which means they're 1. So 2 equal roots is just 1 root. Both of them mean delta is 0. If it asks us to show that it's real, delta is positive. If it shows us to ask they're non-real, delta is negative. So we have to show delta is negative in this case. Okay, so we're not going to try and force it. Okay, we never set the delta equal to anything. If we need to show it, we just calculate delta and prove that that's the case. So first thing, this is going to be on nature of roots. I rewrite this thing in standard form over there on the right, and then I can calculate my delta. I just calculate delta, And what I get if I solve that is negative 11m squared. Now, what do I know about m squared? It's always positive. If a positive thing multiplies with negative 11, it will always be negative. So this thing will always be negative. Negative delta means non-real roots. There, I've solved it. Okay. Next one, B. They give us something like this. Okay, so now I'll talk about what I did on the right as well. They give us a very easy form. So it's literally, we can read negative b plus or minus b squared minus 4ac. So 24 is minus 4ac, 5 is negative b, and 2 is equal to 2a. They could have even just given us 49, and we should be able to know under the bracket it's b squared minus 4ac. So this should be b squared minus 4ac, or delta. They could just give it like that and expect us to still calculate the values of a, b, and c. To get the value of a, right, I just said, okay, 2a is normally underneath here for x, so 2a is equal to 2, a is equal to 1. This is negative b. If negative b is 5, then b is negative 5. To get c, I said minus 4ac is 24. In other words, a was 1, so I substitute back in a, so c is going to be negative 6. Okay, see if you can solve that. The other thing they can ask us about something like this is they could give us this or this and ask us, okay, determine the nature of roots without solving. Okay, so they give us the roots there, but without doing anything else, what are the nature of roots? We can read them off directly, okay? So if we simplify this further, it would be 5 plus or minus 7 over 2, right? So it's going to be some rational number, okay? Would it make sense using just delta? Yes, okay? If we just determine the nature of roots, we can say, well, delta is 49. Okay, 49 is a perfect square. What does a perfect square tell us with nature of roots? It's real because it's positive. There are two unequal roots because it's not equal to 0 and positive. And the last thing, since it's a perfect square, it's rational, which gives us what we actually expect and what this equation at the top actually tells us. Okay. The next thing is they give us something like this. Okay, they tell us what the roots are. You got one like this in the other test as well. If we know what the roots are, this is like the third form of a parabola. X minus x1, x minus x2 is equal to 0, right? So I know this, right? If I set this equal to 0, I'd get this as a solution. If I set this equal to 0, I'd get that as a solution. So this would be my basic equation. Now at the top they give us that b is equal to 5. So I can first multiply out this and check what I get. Okay, we know a, b, and c are integers. Okay, that's why I said element z, just to show the question said they're integers. Okay, so I can multiply away with the LCD quickly and just get 21, negative 14 plus 15x and minus 10, simplify a bit, and I get this equation. Okay, great, but it doesn't look like this yet. Okay, I have that my b value is 5. To make the b value 5, I'd need to multiply this entire expression by 5, which I then say b value is 5, so multiply by 5. If I do that, I get 105x squared plus 5x minus 50. This would be my equation. So in other words, a is 105 and c is negative 50. Okay, so that's the full solution. Let me just show it in one shot so you can pause and look at it. Okay. So the last one, okay, this one was the difficult one. You need to know how to do applications like these types of questions though. Okay, so they give us this right angle triangle. Okay, so by putting a rectangle in there, I basically have a rectangle. I have two little right angle triangles in there and one big right angle triangle there. Okay, they want the area if this is equal to this, and they tell us CD is x. So if both were equal to x, which would just be x squared. Okay, but I can get an actual answer for this because they give me other values, the 4 and the 3. I can even use Pythagoras to say that's 5. It's not going to help me in this case, but I showed it anyway. Okay, so this one involves a bit of thinking. We're going to have to work with areas. Okay, so we can say the area. Okay, let me just see where I went. Okay, so I went with the second paper. I'll just show this up top. Okay, so from here, I went the area of the rectangle, right? Is length times breadth. If both are equal to x, then it will just be x squared, right? The area of the large triangle is a half of the base times the perpendicular height. So in other words, half of 3 times 4, which is 6. Okay, so I know the area of the entire rectangle. I know the area in terms of x of my rectangle and my triangle. I know that these three areas added together must equal the large area 6. Okay, I'm going to use that information now. So I'm going to calculate the area of the two small triangles. Okay, half base times height. Okay, so how do I get the base of ABF? ABF, the base is equal to this, is x. What is this one equal to? 4 minus the length of that, x. Okay, great. And for FDE, I just say the base is going to be 3 minus x, and the height is going to be x. Okay, because they literally told me this is x, that is x for this question. Okay, so then using that information, I've calculated the rectangle up top, I've calculated the big triangle, I've calculated the two smaller triangles. Now I'm saying that the two smaller triangles plus the rectangle is equal to 7 over 2. This entire thing, what are the two small triangles plus the rectangle equal? It equals the big triangle. Okay, so in other words, 6 must equal 7 over 2x. Okay, which means I can solve for x. Again, I didn't use a calculator, so just check that my maths is mathsing. And I get what the value of x is. How will this help me? It asks me to get the area of a rectangle, which is x squared. If I have x, getting x squared is quite easy. Again, just check my calculations, no triangle, and remember the units of area is meters squared. Okay, so this one, you should be able to understand the logic behind a question like this. So let me just show you the entire thing in one. Okay, no, it's not even going to work. So I'll just show this. This is the calculation. So there we get that. Then there was one slightly harder question, which asked us to get the maximum area. Okay, now this maximum area is going to rely on our knowledge of what quadratic functions are. And if we know parabolas, that's going to help us. Okay, so we know area is length times breadth. Okay. If I look at this little triangle, let me just find my paper where I drew the triangle. Yes, here. Okay, if I look at this little triangle, the hint in the question said draw like a Cartesian plane and said this is the origin. Then you can define the line AE by a function. Okay, so if you know straight lines well, you know that we'd be able to define the line AE as, let me just see. Wait, let's quickly see if I missed something here, if I went too far without giving you information. Okay, not really, but let me show you the line AE, okay? So if I go and look at this line AE, I can define it by the function negative 4 over 3x plus 4. That's just the line of this. If the origin was at C, that was my y-axis, this was my x-axis. I can use this to say this length FD will always be equal to the top, the line, minus the bottom, which is 0. So it will just always be equal to the length of this, right? The y value over there will give me the length of FD. Okay, so this function of this line will tell me if I vary x, what will my y value be? In other words, what will the length of FD be? Okay, so when I use that, I can say, okay, length times breadth is going to be x, and we have that the length I said is by that function, which is the 4 over 3x plus 4, and the breadth is equal to x. Okay, they told us this is the length x between C and D. Okay, so this would be the formula in general for the size of any random little rectangle in there if I vary x. To get the maximum size of this, I can notice what does that look like? The formula of a parabola. I can go and sketch it over there, just calculated. If we set this function equal to 0, we get the roots. The roots are going to be 3 and 0. So 3 and 0. The axis of symmetry would be where the turning point is, which is at halfway between these 2 points, 3 over 2. If I substitute 3 over 2 back into the formula for my area, which I've done here, So I use that formula for the area, just substituted the x-coordinate of the turning point, then I get the y-coordinate of the turning point, which would be the maximum value of this graph. This graph is the graph of the size of the area. Okay, so this is a more complex question. Think about it for a bit, but this would be the solution. Maximum area would be 3 square meters. Just remember your unit, square meters as well.